right, that means we're good. Okay, so what we're going to do for today in Grasshopper Space, we have this much to get through. You can see the fun one down here where we're going to start doing attractor points or attractor curve in this case. But first, we're actually going to take a look at these two, which is box morph and surface morph. And you saw the example of that Museo Sumaya in Mexico City. And that's also in our homework assignment, right? And that's really, it's similar in that you're taking a unit, right? You have a unit and you're morphing that unit. So you're taking this kind of flat XY oriented piece and then flipping it and kind of placing it on this secondary, more complex surface. And that's really all it is. So we're going to talk through a couple of ways to do that, and then we'll work on that secondary part, which is applying an attractor curve within that same grid. Okay, and it's a little bit of a different approach, so I hope it's not it doesn't get too confusing between the two. So I'm going to take a break in between. Right, we'll do box morph, surface morph, take a break, and then come back to the attractor point and attractor curve. Okay. And for the homework, you don't have to do an attractor. I was just noticing that we didn't actually include it in the syllabus, and I think that is such a key part of Grasshopper that I don't know. I'd like to go over it. So that'll be the second half of class. Okay. So box morph. Let's take a look at what it does. Okay, I'm going to turn on my custom preview, perspective. Yeah, it's pretty wild, huh? So box morph has a couple of things. I have some reference geometry here and a reference surface. Okay. So my reference surface, you can see, is this warpy. It's not flat. It's not a plane. It's this complex surface, complex curvature, which is also now deforming my unit. But it's coming from that unit. It's just coming from a pre-modeled unit, okay, of whatever thing I want to array. Notice this is, if you watched Professor Peluso's tutorial, I tried to make the same unit here, okay. So you can use anything. You don't have to use that. But I do think it's kind of a neat design. So I just wanted to see what it looked like recreated. So that's box morph, okay. So we'll walk through that first, and then we'll go through the secondary part, okay. So we'll need to make a couple of things in Rhino space in order to really get box morph working for us. So we need this base surface, okay, here, and we need this some sort of unit geometry. Okay. So I'm going to do those first. I'm going to turn off my Grasshopper preview, and then I'm going to go into my Rhino space here and model these things. So I've set up my layers here so that they're somewhat helpful. Okay, so I have my massing, which is going to pretend to be my building. I have my unit on a separate layer, and then I have my secondary, my warped surface on a third layer. Okay. So I'm going to turn off that unit for now, and we'll just focus on this guy. Okay, so what this is really is from a box. Okay, let's turn on ghosted so we can kind of see that. This is just a box. Okay, so I'm going to go in my massing, select the box, and then if you want to, you can turn on grid snap and draw your box. Okay. off, grid snap, and then and of course it doesn't have to be this size and shape, right? I'm just showing an example. So then I need another surface here. So there's a couple of ways I can do it, right? I can type in a plane, but I could also just type in extract surface. And what you want to make sure then is that copy is yes. Okay, so that when I click on my surfaces to extract, okay, extruded surface here, and press enter, it will create a copy of that surface. Okay, so if I move this over, you can see that that surface is still there. If it's not yes, that will just totally it'll separate the surface from your massing, which might not be what you want. Okay, so this way we still have our secondary, what is going to be our facade surface, and then the mass is still there. Okay, so this I'm going to change the layer of. So on massing, I want to put it on surf. Okay, maybe I should have a different color for that. Wow, I don't really like that. Aquamarine, clear. Okay, so then the next step is to rebuild the surface. I'm going to just keep the same divisions here, but what it will do is it will give us more control points. So if I type in points on, click on my surface layer, lock my massing, now I can select points pretty freely, holding shift, and selecting them. Okay. And then I can hold control to deselect. So if I want to keep my corner points at the corners, I can just click on them. Okay. And then I can start to move these this is in the Y direction. Okay. And then he does this little lift up here, which is nice. Okay. All right. So that's our kind of base surface, right? So we can bring that into Grasshopper space already since we've made it. So we can type in surf and choose the surface capsule. Right click, set one surface, choose our surface, and now he's in there. Okay. We can even click default and turn it off, and turn my preview back on. Okay. Now we can see him. Okay. So that's going to be our base surface. I'm going to group it, right click, make it a blob, and then I right click and I type in ref, just so I know that that's a reference that I need to grab. So if I open this Grasshopper in a new Rhino file, I know I have to make these things. Or if it's disconnected from my Rhino file, I know I have to select these things. Okay, so I'm going to change the color too. I make it something special. And that's there. Okay. So then the next thing that we need for a reference is that unit. Okay, so we can go ahead and draw some unit. You don't have to draw the same thing, okay? But I'm going to take another crack at what exactly this is. Okay, so again, we have to turn grid snap on. We use rectangle, and then you can see it snap to the grid. If you want to make it a square or whatever shape, square is probably best because that's how we're going to be dividing the surface. You don't necessarily need to, but you'd want, in order to keep that ratio the same, if you're going to divide the surface that is your going to be morphed surface into squares, you would want your base unit to also be a square, because that, if it is a square to a rectangle, it will start to deform that unit to fit the box that it's being referenced to. Okay, So let's then draw this shape. So we have over here our interpolated curve through points, okay? And it's set to 3. I do not want this to go to my center, so I'm going to deselect that, and then just select the midpoint. Turn off my grid snap, okay, and also turn off my ortho, so I have some freedom here, and then select a midpoint along the path from this midpoint to this midpoint, okay, an approximation, and then if you select it, you can start to hold shift and select these control points to give it some more breathing room on these ends, right? If we want to mirror it, like in this shape, we have to pull these up. I'm also going to do this, right? Pull those guys. Okay. And then I can select that, select mirror, and join them.
Does it have to touch the each edge of the square, or?
It doesn't. No. So what we'll end up doing is from this bounding box, or from, sorry, I'm saying that backwards. From this shape, we're going to apply in Grasshopper what is called a bounding box, which will assume it will make a box about the furthest most edges, whatever is tangent to those furthest most points. Okay, we used that actually in the waffle slab week. So when we made that waffle structure, we used bounding box. So it doesn't really matter if we keep to this rectangle. This is this square, I guess, since this is our guide. So it's not necessary that you have to follow this. It's just so that you have a place for your points to click onto, right? So you can find the midpoint of each one. Okay, does that make sense?
Mm-hmm.
Yeah. Okay. Cool. Yeah. This is. We could actually delete it at this point. We don't need it. What we care about is this shape. So, and what we also need to do then, we need to offset this. So let's offset. Okay. It looks like my distance is set to 0.25 and I'm in feet, so it's about 3 inches. Okay, that works. Okay, and then I would like to fillet those because there's kind of a sharp point. It's not bad, but that's another thing that we can do. So type in fillet, a radius of say 0.5. Maybe that's too much. Maybe 0.35. Let's see. Ooh, yeah, that's a lot. Fillet. Let's do 0.125. There, that's better. Even so, that's a little intense, huh? Not bad. Okay, I might even fillet these guys too, since we're... Okay. So if I select them, I can see that they are what? Closed polycurve. Good. Okay, that's what I want. And then if I select them, I can type in planar surf, and it will create a planar surface from those curves. Okay, you can see that here. Planar surf. Okay, and then if I select extrude surf, then I can extrude this. And here we don't really care about the height too much. We just need there to be some height. Okay. Actually, I'm going to redo that. Extrude surf, because what I can do is I can change this delete input from no to yes, so that when I do extrude it, I don't have that original surface still hanging around, you know, and that way when I select this, it's either the curves or the surface. Okay, so now we have our unit. one poly surface. So I can select him. Okay. Looks good. Okay, I can select him, go back to my grasshopper space, and then I'm just going to bring down a geometry capsule. Okay, so geometry here. Right click, set one geometry. Right, cool. Control G, right click, blob, right click, color, and we get some funky color. I want those to be the same. Okay. And I'm again going to just say this as a reference. Okay. All right, so now I can probably turn off, I can go to my default, turn off my unit because it's now in Grasshopper. And I'm going to hide this so they're massing. Okay, that way it's not distracting us. And then I can see that I have my two things set up. Okay, so now that we have our reference geometry in Grasshopper space, we can start to connect these things. So the first thing we need to do is we need to use the same trick that should be an old hat at this point. So it is ISO trim. Right? We're going to create subsurfaces to for this unit to be placed onto this surface. Okay. So we have ISO trim. We have divide domain. Okay. The surface goes into our domain and our surface for ISO trim, and then our divide domain goes into our domain. Okay. So that, I think we've done that probably 4 times now, so I think it should be, yeah, pretty familiar. The other thing we had was I created a UV count that was the same. Again, that was because I used a square to make my unit, so that's, you know, a nice symmetrical unit, and I want it to be applied in the same way. So I'm going to use the same strategy here where I have my U and my V count as the same, right? These are mostly squares with a little bit of warping. Okay. All right, so that's my base surface. So then from that, what I needed to do was I needed to pull what is called a surface box. Okay, surface box. So what that'll do for us, we actually saw that in Younghoon's homework. We saw the surface box. So we need to give it a surface, right? That's our input. And then we have the domain here. But what that does for us is it gives us a box that is referenced from the surface, the base surface that we've made. Okay, and you can see how that conforms to that really nicely. So that's where our unit is going to go into using the box morph. Okay. So we have our surface box. We need some height. So let's say 1.5. Ooh, that might be a lot. I'm going to right click, edit, change my digits to a little bit finer. That way I can kind of move this, gradually move this in and out from my surface. So this is going to be what controls the height for us. Okay, so the height of this unit. Right, so I'm going to control G, and I'm just going to say height. Right, and then I'm going to group this. Okay. Scribble, and this becomes our kind of, yeah, we'll just say base surface box.
Sorry, what's the last thing? Because I realized that my units were wrong, so I have to fix that. So I'm kind of behind. What's the very last thing?
Okay, all right. Well, here, we'll just zoom in and take a look. Oh yeah, that's a good point. We should check our units. So I'm working in feet. You could probably work in another unit, but I prefer to kind of just keep it in feet, and that way I know if um, my 0.25 or 0.5 or whatever, I already know to translate that to inches. It's much more difficult, I think, to count up than it is to count down. For instance, if I'm in the hundreds of inches, that starts to get to be a lot of math to do quickly. Okay, so what we have here is we have our base surface, and we use the same trick that we've used previously in that Nervy dome, and gosh, quite a few. I think we also did it for the tower. We looked at that, um, but it's this isotrim plus the divide domain. And then what I said was we should probably try to keep our U and V count the same for this particular unit because it is a square that we drew it in. And these are now squares that we are going to be applying them into. And then once we build up that divided surface, then we're going to create this, we brought down a surface box. And a surface box has these three inputs. So you have your surface, your subsurfaces, right, from your isotrim. Then you have your domain, which is from the divide domain squared. And then you have your height. And this height is going to be what is controlling the height of your morph, okay, whatever your morphed object is. So you can see that here as you gradually shift that up. Okay. And notice I haven't touched this reference geometry yet. He's just kind of waiting. Waiting for this next move. So we did the surface box. So next we need to bring down the box morph. Okay. So we'll bring down box morph. Okay. And box morph has three inputs. So you have your geometry, which is the geometry that is our here. Okay. Our reference geometry. You have your reference reference box that we need to create, and then you have your target. So we need another capsule after the geometry here, and that's that bounding box that I was talking about. So we need bounding box, this guy. Okay, solve-oriented geometry. So we need our content to be our geometry here. Okay, and you can see how that created this box that is going to be at the tangent of the furthest points. So in top view, looks like that. And that's why I was saying it doesn't matter so much if you follow the base shape or not, because it's the bounding box will just assume that geometry anyways. So whatever you've drawn, it will create a box about. Okay, so then the next part is to start to connect these. So geometry to geometry seems pretty obvious, right? So we have our unit, and our unit has to be the thing that is being morphed. Then we have our reference, which is going to be the bounding box. That's the kind of the rectilinear box that is going to be our reference for the morphed, for the morph to take that box and place it on the surface. So we'll take the surface box then as our target. Okay, and then you can see it should update like so, where you've now given it the unit, you've given it a reference box to approximate to using the surface box as the morph location. Okay, so it's kind of key. You have to have these two other capsules for box morph to understand your complex geometry that you've made. So whatever unit you have, you should really have the bounding box after that, and then surface box to reference to. Okay, I'm going to turn this off just so we see. Okay. But yeah, so it's kind of a nice simple a simple technique, right? It's not too complicated. so long as you make sure that you know to have these two additional capsules for your box morph. Simple and effective, yeah. So, and then when we could probably also, we have, I think I did a custom preview, so we can add some color to this. Okay, geometry goes here, and then we do some other sort of color. We can do color picker, color swatch, do swatch. Ooh, white's a lot, so let's do something else. That is very, I don't know why I'm into lime green this week. Maybe something like that's a little better. It's harmful on the eyes. So yeah, so there's that's it pretty much. That's box morph. That's how you use it. There are limitations, which is we can't use this on a trimmed surface. Okay, does not work on a trimmed surface. So this base surface, if we were to cut him, the grasshopper would still continue to approximate the original surface, like so. So that's one limitation. The other one is that you really can't use the bounding box is only for the one piece of geometry. So every time you add a piece of geometry, you're going to also need the bounding box of that geometry. So something else to kind of keep in mind as you're using this. Okay, so you can't just plug in 3 different things and then have bounding box do it. You might be able to, yeah, no, it's better practice just to keep one geometry and one bounding box. You'll know it works then. Okay, so let's turn this off. And if you want to bake it, you can, but that's really all there is to it. Notice it's a very simple, quick script. So I'm just going to pull this over and zoom in here so that I'll give you about 10-15 seconds to just double check that all the things are working correctly, but I would assume it's fairly straightforward. Okay. So we have surface, we have our 2 reference pieces, isotrim and divide domain, box morph, row surface box for this, and then we have box morph needing the bounding box as a reference from our geometry, and then custom preview. Okay, so that's base, that's our surface, our box morph with surface box and bounding box. So let's move on. We'll take a look at box morph. Okay. Oh, sorry, surface morph. Reading and not thinking. Okay. So here I've also used for surface morph. This is a little bit different, a script. Okay. So, but it kind of similar in that we're taking some unit. Let's look at what the end goal is here. We're taking some unit, but the unit is actually the whole surface. So it's a pattern across a surface that's on a flat surface, and then you're morphing that whole thing and it's referencing onto a more complex surface. Okay, so you can see here I have a Voronoi pattern that I've done. It's on actually a flat surface. So if we look at here, okay, you can see here it's actually in a flat plane. Okay, and I've drawn this, or I just have some pattern that I have drawn in a flat plane, but I want it to go onto a complex form like this. Okay, so that's what surface morph will do for us. Whereas box morph is more, we have a unit and we want that unit to be arrayed as an individual thing across a surface. Surface morph is more like we have this large pattern. The pattern's also going to go on the whole thing. So let's look at how we do that. Okay, so we have the same, actually still the same reference surface from the previous box morph. So if you want to, you can just copy and paste that. Okay, I'm going to move this down. Okay, so I literally copied and pasted that. So that was my start. Copy, paste. Okay. And notice I have nothing on right now just because for clarity. So we're going to turn this off too. Okay. And then what I did from this, because I know that my complex surface is going to be this big and this location and everything, ideally you already have it figured out, you know, what that geometry is going to be, and now you're just applying the pattern to it. So, and even so, if you didn't, like if these dimensions were to change, we have in Grasshopper here this secondary little script, which is we take the dimensions of the surface, okay, because we need to make a planar surface that is similar in shape. So that's what this does for us. It takes the dimensions of our base surface and then we'll make a planar surface that's of the same size so that there isn't any, well, it'll still warp onto the surface, but there isn't warping or distortion based on the difference from the reference surface to the goal surface, right? We want those to be the same size at least in X and Y. Okay, so that's what this is going to do for us. So we need to bring down dimensions to pull out the dimensions of, here they are, dimensions. That'll give us the, what is the U and the V, or otherwise, but which is also X and Y of the base surface. Okay, so if we hover over it, we'll see it's 12 in the X direction, and then V is actually going to be in this direction, right? Because we've reoriented it. So it's 13 in this direction, 13 something or other. So if we want to make a copy of this plane or a reference plane that's all flat for us to draw on, then we'll make a plane surface, create a plane surface, okay? And that's going to, of course, go for our 0, 0. And it has these defaults X and Y. So all we need to do is we need to give the U dimension to our X and the V dimension to our Y. And it will create what will then be our reference plane that we're going to draw in. And it's kind of nice if you do it this way in Grasshopper instead of, you know, because you could do this in Rhinospace too, but if you have this set up in Grasshopper, then as you adjust this surface, this will adjust as well. So, okay, so I'm going to group those. I'll follow what I've done. Okay, so I'll say planar surface. Group these. Okay, I'm going to turn this off, this original surface, just because he's kind of distracting. For what we're going to do, we're going to start working now with the planar surface. All right, we need to fill that out with some sort of pattern that we're then going to morph onto that complex surface. So let's take a look at what we're going to do. So I chose the Voronoi pattern here. Okay, but in order to do a Voronoi, we needed some sort of points within the space for the Voronoi to approximate geometry to. We need some sort of point system. Okay, so we can see that if we bring down a Voronoi here. It's a planar Voronoi diagram. Okay, from a collection of points. And then we need our points, so we need to populate 2D. Okay, there's populate 2D and there's populate 3D. 3D will obviously go for a three-dimensional object, okay, whereas 2D is a planar
Will
object like this.
it still do the same if you do the Voronoi 3D? Because that That's what I chose, but I don't think that was the right one.
Right, so actually, yeah, you would want to use, so no, you want to use this one right now, the Voronoi with it's the three separate um, conditions, because this is the planar version. Voronoi 3D would populate a three-dimensional volume. And actually what I was just talking about, the populate 3D, you would want to use populate 3D for that one, right? Because you need to fill that volume with points. But we're just going to work in the planar field right now, so you would want populate 2D to work with this planar version of a Voronoi pattern. Okay, here, this planar Voronoi diagram. Okay, and it should look like this, where you have your points, your boundary, your radius. And that's just, I'm going to bring down that. What's the difference? Ooh, Voronoi overdose, yeah. Right, because you need some sort of volume to fill with those points. And we're not going to work on that right now. We're going to just keep it planar, because we need the plane to then morph onto another plane or surface. Okay, so we have our populate 2D and we have our Voronoi 2D. Okay, so population is going to be our points for our Voronoi. Okay, you can see that update. But then we need to fill in, there's a region that we actually want this to be working in, so that's going to be our plane. Okay, so you can see the points now update, they're working within the plane that we have referenced. And then the Voronoi needs some boundary, and that's also going to be our plane. Okay. So it should look something like this, where we have the Voronoi pattern creating the cells for us about our planar surface, and those are coming from this populate 2D. And the fun thing about this is that you can start to adjust this. Okay, the populate 2D. We could type in a count, okay, where we start to increase or reduce the number of points that we have in that region. We can also give it a seed. Okay, so it's the kind of randomizer button, I would say. It's telling it how, it's kind of a, yeah, well, you'll see here. It's telling it kind of a random location, like algorithm, I guess. And this is your control, where you get to kind of change what that is. Okay. So just knowing that you have these other controls here. Okay, points to the list, we don't need that. Okay, so we can probably group this. Okay, we don't need the plane, and we could give a radius, but I'm going to keep it as so. So we'll just group scribble, and then we'll say that this is our Voronoi pattern. Okay. Click add to group. All right, so we have our 2D Voronoi pattern set up. Now it's a matter of, we need to work to offset those lines that we see, right? These are each a cell, and they're, I wonder if we can't do a list item to see that. There we go. So this is really just a series of closed polylines as our cells. So what we want to do, if you remember, this has some sort of thickness to it, okay? You can see here there's a thickness to the geometry. There's a width. There's also a height, but the height is relatively simple, right? Because that's the, it just extrude, okay? But the offset, we need to kind of work to get that distance. So we're going to take a crack at scripting. Okay, so we're going to actually script this offset. I don't know if you've used any Python in other classes. I actually don't know, maybe you need Python in your computer. I didn't think about that. Ooh. You might have had to download this. Can you guys try that? I didn't think about that. I've had it on here so long. If you type in Python, GH Python script. I'm not sure if Rhino 6 is up, because they might have integrated
I
it.
have it.
I have it.
You guys have it? Okay, all
Yeah.
right. Okay, yeah, because it used to be I think you had to download it separately for Rhino 5, and then I want to say that for Rhino 6, when they integrated Grasshopper into it, and then I think they also integrated the Python plugin as well, so it was no longer a separate plugin. So if you don't have this, like, just follow along, because I did try it the other way, okay, which is offset curve. Offset curve here, okay. This is essentially what we want to do. We want to use this capsule. However, if we use that capsule, it gets to be quite messy, and there's a lot of overlap in our curves, so it doesn't really work. So we have to use a little bit of script to kind of offset that cleanly. Okay, so let's take a look at how we do this. Okay, so if you haven't used, I actually don't use Python that much. I usually am able to do most of what I want without it. However, there are some cases where it's helpful, and this is one of them. So if we take a look at what this is, there's an X and a Y as our inputs, and then there's some output. And really what this capsule is it's us writing in our own script. Okay, so each one of these capsules is really kind of script inside of it that is producing it has some function, right? So you put in some inputs and then there's an output. And in between here and there, there's a kind of unseen script that is working those numbers or working that geometry. Okay, so that's kind of what this is doing here for us. So I have, you can see here that this one that I have set up, I have 3 inputs, and then I have 2 outputs. The out here is some text, and then the out here is going to be some variable. Okay, so we will actually use the A as our output, but we do need to change. We need to go and zoom in here and add a 3rd input. Okay, you can see that. 3rd input, and then we need to right click, and I'm going to change the names of these. So I don't know if you remember last week, I think it was, we had to change, I had that trouble with the X, right? I said variable X, and I needed to change it to X. So, and that was because whatever I had in my script had to match the input label, whatever the label is. And this is where computers are incredibly smart, but then there's also this point where they're incredibly dumb because they can't make leaps like us, right? Where we can infer data, right? We can look at one thing and say, oh, this is U and V, that must be X and Y or X and Z, depending on the orientation. And like all of that processing that just has happened in our brain, we actually have to literally tell the computer all of that translation, right? So, so here we have, oh, I should probably do this again since I talked a little bit. Okay, so I'm going to right click on my X. I'm going to rename this CRV for the curve input that's going to be put in. Okay, right click here and relabel this DIR for the direction, which is going to be the offset direction. Okay, and right click here, which is going to be DIS, which will, DIS, no T, which is going to be the distance. Okay. And then now that I have those 3 things set up, what I'm going to do is I'm going to double click in here. If I double click this, this Python script editor will open for us. And in here, I need to type this, type in this script. Okay, that's our script to type in. So I'm going to press enter twice. So I'm in row 13. I'll type in A equals RS dot. And what should appear here is this list of commands. Okay, so I'm going to continue to type, and we'll do offset curve. And I think I can't click on it. Yeah, I think I need to keep curve, offset curve. And I'm also going to make sure that everything is the same, including my capitals. Okay, offset curve. And then I need to give that some labels, right? We need to give it the same labels that we gave for our 3 inputs, which is we have a curve that we want to offset, we have a direction that we want to offset it to, and we have a distance that has. Okay. And then I have to have my enclosing parentheses, and then I can click OK. Okay. So it should follow this exactly. Okay. So then we start to enter these inputs, okay, from the wires. So I need my Voronoi cells as my curves. Okay. My direction is going to be from my my points. Okay, so we'll be moving from those. And then we need some offset distance. And you can see here I've left a reminder for myself. I said, be careful, slow. And that is when I'm starting to change this. So later in the script, when I start to build all of this other information on top of it, when I start to change this, it gets very, very slow. So I want to be a little cognizant that what I'm going to set up right now is something that I want, okay, so that I don't have to change it later. Okay, so I had, what did I have here? I had point, I did 3 decimal, okay. Point, let's see, 100. Okay, I'll give it a distance. And right now it's fine, right? So we give it a distance and it's all good. But as we, like I said, as I start to build it up, then it does not like it anymore. Okay, and you can see that this is very clean, right? The way that these are offset from those cells. Okay, so it's taking those curves that I did the list item from, right? It's taking each one of those and offsetting it towards the interior point, right? The direction is to the point from that curve. And then we have the distance, which is going to be, I think I have 0.1, so it's, you know, something like an inch or so. And then the thickness will be that, whatever is from both those offset curves. Okay, so that's the scripting part. That's the tricky condition. And I almost wonder if I shouldn't show, we'll do offset, and then we'll say script me. And then we'll also give this distance and kind of a grouping with that beware. Okay, and then we can group this. Okay, I can probably turn off these things now. So we just see our offset curves. I was almost thinking that I should show, and maybe you already tested it, but how that offset curve, I don't want you to get too confused, but if we were to try to offset the curves, you have a curve here, okay, Then you have your distance, and then yeah, you see that how it starts to move. It's offsetting it in the opposite direction. So we really need, like, this offset curve really needs a directional component, which we get with our script, but not in the offset curve. So that's the addition to what this is doing for us. It's saying we want it to move this way and not this way. Another level of control, right? Okay, so now that we have those, we can start to create surfaces, okay, between these spaces. So let's grab, I had my region difference, okay? So we're going to have boundary surfaces, which are going to work in between these offset surfaces, but we need to grab a region difference to work between the Voronoi cells themselves and the offset. Okay, so region difference is going to, oh, this is distracting. Okay, region difference. Region difference is kind of going to work as a cutter for us. Okay, so we have our curves that are going to be the cells themselves. Okay, and then we have the Python script, the A output, which is going to be these secondary offset cells. Okay, and when you do that, it's going to take some time. So you saw my computer just give it a think. And then the other thing is we have to flatten this. So we're not seeing the result right now very clearly, but if we look at our lists, if we take a panel, remember, if we're having the lists talk to each other, we have to make sure that both lists are the same. So you can see here that the Voronoi cells that I'm using to kind of cut my my offset, this is a flattened list and this is a grafted list. So just by right-clicking this and choosing flatten, we'll get these lists to be the same and should have a clearer a difference, a clear cut. Okay, and we could flatten this as well, right? We could flatten either of these, but the point is that we're flattening, we're changing this list to look like this. Maybe, I wonder if I shouldn't just do that over here, and then you can see it. We'll right click and we'll choose flatten. There we go. So now you can see that they're both the same, right? And that doesn't have to be flattened because I already flattened it. But yeah, this guy he's pretty slow. He's doing a lot of work. Okay, so now we have the region difference. What we want to take is we want to take a boundary surface. Okay, and we'll input this into the boundary surface. Okay, I'm going to turn this guy off. Turn this guy off. And then you can kind of see what happens. Okay, so you have your original cell, and then you have your offset cell, and these are kind of, they're creating some sort of region in between the original cell and the offset cell. So he's kind of saying that this is our cut edge, and and as are the offset surfaces. And then in between them, we're getting some sort of boundary surface. So it's taking those cell edges and it's starting to create some sort of surface in between them. Okay. The problem is, of course, that it's completely flat. So we need to do some extrusion. But that's pretty simple, right? If we just do is an extrude, we have our surfaces to extrude, and then we need to give it some height, which will be Z. Okay. There we are, yeah. Okay, and then if we want to give it a factor, I think our default is 1. So if we give it 0.55, we can start to kind of control that a little bit. So I think what's going to happen is we're not going to have the same, I think the height might not matter again once we get to our surface morph, right? Because the height was being controlled by surface morph and not whatever the original geometry is.
Mine's not working the same.
Which part is not working?
Like the when you did the edge surface, like it created like an entire surface, so it doesn't like it's not like where like the lines are, like where the curves are.
It created an entire surface. You're saying about this whole thing, right?
Mm-hmm.
I'm guessing, did you grab a region difference?
Mm-hmm.
Okay.
Oh, okay. It's just I figured it out. I've just flattened one of them, and that's how it happened.
You do need to flatten the B curves. Okay, so the A, it does matter which where like which is A and which is B. Okay, so your A is going to be the Voronoi cells, and that doesn't have to be flattened because that list is already one list. Okay, and so what we need to flatten is the Python script that we ran. So we need to flatten the offset curves, where that, if I unflatten this, would be a list of lists, right? Each one has its own separate line item. So by flattening it, I get it to be one list, similar to this guy. And then when I take region difference, um, I should get a result that is um, a, a region between the curve A, which is our cell, original cell, and curve B, which is our offset cell.
Yeah, I just flattened the wrong one. I flattened A instead of
Ah,
I didn't because I didn't realize that, like the certain curve had to be flattened.
well, it's right, a certain list had to be flattened. Yeah, yeah, because the curves are already flat, right? It's the list here that needs to match. Does that make sense? So if I copy and paste this and I don't flatten it, and we take a look and we compare these two outputs, you'll see that one is very different from the other, right? And that's why we're flattening them, because this curve A, this list and this list both need to be the same. Okay, so we have a flattened list for A. That means we need a flattened list for the B curves. And if we look at the original output of our script, what it does is it gives us a separate list for each curve, which is not going to talk to this list, right? There's a 0 line item, and only the 0 line item will talk. But the rest of them don't know how to communicate. So what flattening does for us, right-click flatten, it gives us the same format as the original curve A list, and then now they can speak to each other, right? Now they can start to draw conclusions that 0 and 0 have to create a region, and 1 and 1 have to create a region, and so forth. So yeah, I don't know if maybe I didn't explain that very clearly, but um, that's That's what we should see going into this. And then from that, you have a region that's made between the two curves, and that will be our boundary surface. We could probably turn that off, actually, preview off, and then just look at the extrusion. And the extrusion then will be, it's going to act like our unit for the box morph idea, right? Where it's like this thing that's a pattern. And now we're going to go back, look at our original surface, and we want to apply this pattern to this. So this is where we need that surface. So we need the surface morph. Okay. So surface morph, we can bring down surface morph here. Okay. Surface morph, you should see a whole bunch of inputs. You have your geometry, your reference, your surface, and then a whole bunch of domains. Okay, so the geometry is going to be fairly straightforward again. It should be this extrusion that we've made, right? And then the surface that we want to apply to is going to be this original surface. So we have to go back to the front, way to the front of our script, pull that surface and drag it over. Or we can type in another surface capsule, right? We can do this trick where we bring in the same geometry. It's identical. It's just a reference of that. And then we can pull that capsule over so that we have that over here as a reference for us to know where that's coming from. Okay, and then input that into our surface. We can hide the wire display hidden so that it's still listening for that information, but it's not crossing our wires across our script. Okay, and you could probably box that and just say this is some sort of reference in Grasshopper. I'm not going to blob it, I'll just keep it a square, and that way I know it's a Grasshopper reference. Maybe red. Okay. All right, so we have that, but we have our base geometry, we have our surface to reference to. Now we need the reference box, which is going to be the same as before, which we need a bounding box. Okay, so we need some bounding box about this unit that we've made. So we'll type in bounding box. And before we utilize it, you'll see down here that it says per object, and that's what we used previously, right? Per object, where we had a unit, and that was our object, and we wanted to take one object and multiply it across a surface. But now we want to actually change this. So if I double click on, why aren't you working? Oh, there we go, right click. I'm trying to double click my way into it. A right click. Okay, so right click is where we get it. But we want to change this to union box. Okay, and union box is going to take this whole thing as one big unit. Okay, and it's no longer just an object, it's a whole thing. So it's going to take the whole pattern for us. The other thing we want to do with bounding box is we want to already flatten this content that's going to come in, just to make sure that that is one list that's being worked on. Okay. All right, so then we can take our extrusion, and our extrusion can go into the bounding box. Okay. And then we can take our, I think it's the first box, isn't it? Yeah, okay, I thought so. Not really sure why. Oh, oriented to plane, I see. World coordinates, got it. Okay, so we can take the world coordinate one, which is the top, and bring that into our reference, and then give it a moment. It might still, oh, right. It's probably not going to work just yet because we need to give it all of its domain information. So the other thing we need to do is we need to set up this UV domain. Okay, and that's going to kind of be the domains of this surface. Okay, so I'm going to give them each a 1 value. Okay, and if we let it run, you'll see it all works within one tiny cute little inch. Okay, well, that might not be what we actually want, right? We want to extend this across the surface. So what we have to do is we have to I have here reparameterize. We have to reparameterize this base surface so that the domain is not actually measuring the true dimensions of the surface, but is actually going to be kind of remapped from 0 to 1 instead of 0 to 12 or 0 to 13. Okay, so you right click and we click reparameterize. And then it will start to assume the form of that surface, because now it thinks that this is 0 to 1, and we've given a U, V, and W domain each as 1. Okay. The thing with this is that actually I think we kind of want to control this W domain a little bit more, right? Because we have, if this is U and this is V, we want to control that height of our morphed surface. So we're not totally done yet. I think we can give a slider for 1.25 maybe, 1.25, and input that into our U or W demand or W input instead. And that way we have some height control, but it's going to be very slow. Ooh, okay, well. That is the trick with this, is just patience once you start to get these more complicated scripts set up. Okay. All right, I'm going to rename this height, and then 0 to 1 domain. Okay. All right, so I can probably go through and start to turn this off, right? And we don't need those things. And we don't need our base surface on. Don't need this on. We can just see our geometry. Okay, I'm going to pull down a custom preview too. Copy and paste from our previous script. Pull that in, turn it on, and now we have some wildness happening. Ooh. So I don't know if you've tried that, but when you do rendered mode and you have a custom preview on, you'll start to get this overlap of all your custom previews, even if they're off. So you have to go through and disconnect these if you don't want them to run in your rendered or Arctic view or whatever views you have set up. It's kind of an annoying thing. You must be moved over or something. There we go. Yeah, so then, you can start to adjust this. If you do adjust it, you have to kind of know that, these things are, well, they're going to be slow. So if you adjust the base surface, it now has to rerun the script, and you'll get the little spinning wheel of doom and kind of have to be patient. So it's good to have your base surface already maybe figured out a little bit more, you know, so far as using this as a, a maybe form finding study or design finding study, you might not want to do that with the base surface there. You know, figure that out and then apply your morph, because it's, yeah, there you go. Whew. It's going to take you some time. Okay. All right, anything else here? Can probably start to group these. I think I just didn't make, yeah, I didn't make 3D for all of that extrude stuff. So pull that over, scribble, say make 3D. It's a play on the make 2D that we have, right? And this bounding box is here in between the two. And then you have your surface morph reference. So we can probably make that its own thing. Okay. Nope. Keeps turning on all the things. Okay. So I'm going to save this if you haven't already saved it. And I think we're done for this first portion of class. So that's good. That's we made it through pretty quickly, I think. I'm going to leave this up on the screen, and I'll set up a break here. We'll say, let's do 10 minutes. I know 5 is kind of quick. So we'll do 9:55. We'll reconvene, and then we'll try to get through this second part of the script. We might leave this part off just because he's not, he's like an additional, you know, if you wanted to do this, you could. But I think it would be helpful to get through the attractor points for you guys, just to have that in your back pocket for times when, you know, it's useful, because it is. Okay, so I'm going to zoom in to here. Is this good, or do you need more of the script? I think I can probably get. I'm gonna copy and paste this too, so you have that script sitting out. Okay, so I'll leave my screen up, and then yep, I already took a minute of our break. So okay, I'll turn my mic off and camera. Leave that grasshopper script up. 9:55. Okay. Okay, all right, back to the second half. Had to grab a blanket because it is just freezing here. Absolutely cold. If you're not in Chicago and you're in a warmer place, I am happy for you. Okay, so are there any questions on this part before we move on to some attractor points? And that's, you know, surface morph or box morph, um, or really just any of it. Speak now or forever hold your peace. I'm going to do another check here of folks, I think, before, just in case anyone's joined us. Okay. Oh, okay. So I take that as it's clear as a bell, and we can move on. So I'm going to turn this off, preview, and now we'll go into part, I guess, part 2. Okay, let me disconnect this guy. Okay. All right, so attractor points. Let's connect this guy instead, and then we'll turn on what are the attractor points and what are they doing for us. Okay. So, so attractor points are kind of, this is more of a surface manipulation, right? This is kind of giving us a similar effect to like what you would get from a graph mapper, except for now we're not using a graph to control apertures and you know, locations of things. It's now we're using hard geometry, and by hard geometry I mean a point or a curve or some other object that's going to be our you know, where we're going to pull or weight sort of remapped numbers, right? That's what we did last week, where we learned how to remap numbers, and this is set up similarly. We're just using a different capsule to control how we're remapping them. Okay, so if we take a look at how this is set up, we need some sort of grid, arrayed grid. I think that's under here, under vector. If you go under your grid, there's hexagonal, there's radial, rectangular, all these different triangular. So this is some kind of base grid that I pulled down, so I just pulled the hexagonal one. Okay, you can pull another one if you want, but it's going to set up for me this kind of base structure that I will then, you know, obviously start to infill with some sort of weighted, you know, weighted locations based on my this other secondary input, which is my points, right? So I need a grid, and I need a point that's going to act as my attractor along that grid. So if I look at this again, you can see that where those points are, that's where the things are going to be heaviest, and then as you move away, they start to reduce in their diameter. Right, that's really all it is. It's some kind of almost offset, and then there's a surface that's being created between the interior, between the inner offset and the outer offset. So kind of similar to what we did previously, but it's yeah, we're just giving it some attractors. So So we will need to bring down some sort of grid. So I'm going to, I do kind of want to try something new, but I feel like if I try something new and I'm working in, in a recording, that's just a setup for a disaster, right? Because anytime you try to do anything in a recording that's new, or even in class, right, limited time, then it won't work. Then you start to have problems. So, and it sucks up time. So I'm going to bring down the same hexagonal. And we'll just walk through the same thing. Okay, so hexagonal grid, you can see the base one is this kind of like, extent in the Y. You have 5 and 5, and then the plane is going to be the XY plane, and then the size is going to be the size of the cell. So all of these are parameters that we can start to play with to create our sort of hexagonal grid. I'm going to leave the plane as it is, but the size, I can give it some sort of number slider between 0 and 1, since I'm working in feet, right? That way I can make it 6 inches or a foot. And then I'm going to control the X extent and Y extent. I made mine longer in the X direction, shorter in the Y. So we'll give it 30 for our X extent. And I gave it, I guess, 10 my Y, but we'll give it 12, so that way we have some fluidity in the 0 to 100 direction. Okay. Maybe not that short. Okay. So that's my base array that I'm going to set up. Okay, scribble. Okay, group those together. And then if I take a look at what my outputs are, panel, let's take a look at what these things are. Yeah, I have multiple lists here, right? I have a list of lists. This is going to be true for each of these. So I think, yeah, I had to flatten these. So I'm just going to go ahead and flatten both of these lists. Right click, flatten. And that way I have a single list with all of my curves and all of my points. Right, these are going to be my cell curves. They're all in one list, and then I have all of my points, which are going to be all in a separate list. Okay. So once we have that set up, now we're going to want to also set up our attractor points, right? So I have these points that I want to pull use as pulls to get some sort of weighted geometry at those locations. So I'm going to make those in Rhino space, and I think I've already done that here, but I'm just going to, I'll delete these and we'll remake them. Okay. So I made myself a points layer, and what I did was I just went to my point button over here, and I chose the multiple points, and I picked random locations for this, because we're just a tutorial, right? Pretty much it's the exercise for us. But I would think that, for these locations, you could, if it was like a facade or a feature wall or something that is, you have a design intent, you could really start to make pick key locations for those points, so that you have more coverage, right? And private, maybe, more of a private program versus more like open locations for an open program. Right, you can start to like play with justifications of where these points are. But for us, of course, there's not really a good reason. We're just playing. Okay, so in Grasshopper then, so I've noticed I've selected all of them. Okay, in my Rhino space, I made 3 points and I selected all of them. And then in Grasshopper, I'm going to type in point, and I'm going to pull this point container. Okay, and then he's just going to contain, I'm going to right click and set multiple points, and then he's just going to contain that geometry, right? So that as I adjust these, he updates, right? And that's the nice part of referencing it from Rhinospace, is that once you can keep adjusting these quite freely and where you need to, but then Grasshopper will keep that information for you and update your design. Okay, so Control G. Let's right click, blob him, reference him. I'm liking this lime green as the reference. Okay. I have to set my other points again for my original script. So I deleted them. Okay, so then once we have that set up, we have our base array, we have our points. Now we need to get into the remapping of these points and how we're going to adjust the pull on them. Okay, so we need a pull point. Okay, and a pull point is going to let's see, let's take a look at it. Yeah, pull point is going to pull the hexagonal points, okay, that we have. Okay, so this is coming from our hexagonal array. I should use it on mine so we can see what it is. Okay, so this is our center point, right? And what pull point is going to do is it's going to pull from the points that are in our center points of our hexagons. In the geometry that's going to pull them is going to be our attractor points. Okay. So, and then we're going to take that pull point and we're going to remap it. So we're going to take whatever distance from the point that is the center point and the point that is our attractor point, and we're going to find what that range is. Okay, and then that range is going to act as the source, and then we need to remap it and give it a new target, which is a smaller distance than our radius. Okay, which is here, right? We have 0 to 1 set up, and then it needs, but we'll talk about this, why it has to be less than 0 or more than 0 and less than 1, but that's what we're going to remap to. So we need to create some sort of pull on the point, have some sort of domain set up as our minimum distance and our maximum distance between those two, and then we have to remap that and give it some minimum distance and maximum distance within the cell itself. Okay, and then we'll get into how we scale those. Okay, so we're really just scaling. We're not offsetting, right? The scale is the key here, that we're saying that the scale has some sort of factor, and that's the remapped version over here. Okay, so maybe I went a little too far ahead. We'll walk through it and see what that does for us. Okay, so I need a pull point. That's the key. We need a pull point. Here, pull a point to a variety of geometry. Okay, so the points that we're going to pull are going to be our center points for our hexagons. And then the geometry that is going to be the puller is going to be the attractor points that we've set up. Okay. The next thing we need then from the pull point, notice we don't really get too much from it, but if we look at the panel, we do get a series of distances, and that's really what we want. We want the distance from all of these center points to the attractor points. Okay. So we need to remap them, but in order to remap them, we need the to set up a maximum distance, because notice in those distances we're starting to get some pretty high numbers. And so what we want to do is we want to give this some sort of minimum. We're going to say minimum range to work within. So we'll say that we have this distance that's coming in here as our minimum. So it'll set up some sort of smallest part of our domain from the attractor point to the nearest center point. And then it's going to need some maximum. If we input this list as well, it'll give us the maximum distance from this center point to, say, this point, or whatever the largest distance is. Instead, what we want to do is we want to, actually no, that would be maximum. So this one won't work for that. So we need to give it some number, which is going to be, I put 5 here, okay, to say within 5 feet. I want something within 5 feet to be my maximum distance that we're working within, right? So the minimum is going to be, here, we'll pull out a panel. Okay, you can see how there's a number of 5s. And then we're going to have some things like 0.07 and 1.4. So what it's going to do is it's going to give us a result that is within the range of 0 to 5. And actually, it's not even going to be true 0. It's going to be whatever that smallest distance is within the attractor point to the center point. And then anything that's larger than 5, it will replace with 5. Okay, so that gives us some sort of limit here, and it says within 5 feet we're going to control it, and then outside of that we don't really care. So as we adjust this, that adjusts as well, right? That number starts to change, and we start to pull points that are within, within further ranges. Okay, but right now we'll just set it to 5 for this. Okay. All right, so then once we have that, if we pull down a bounds, right, I have a bounds here. Bounds will tell us that information. It will actually tell us, why do I keep deleting a panel? They're so helpful. Bounds will tell us what that minimum is, what that smallest a value is. So it looks like, see how it's not true 0. It's actually, oh, I have this set to 4. It's actually 0.3 something. If I change this to 5, now it's 0.3 to 5. Okay, so we're going to work within a 5-foot diameter of these points. Okay, so now we need to work our remap numbers, right? So we have to remap these to adjust the scale within 1 foot of itself. So we're going to take our value, which is our values, which are the all of these numbers that we saw that list. We need some sort of domain, right? Source domain, which is going to be our bounds from 0.3 to 5. And then we need to have a target, and the target is going to be our constructed domain. Okay, so construct domain. And this is going to be the domain that we set that is going to be what is the closing and opening of these guys. So we don't want that to be truly 0, okay, because it's kind of, if you think of it like a percentage, 0 would be, there's absolutely no scaling to it, and then 1, it will also do, it's full scaling, so it's going to just lapse upon itself, and it won't, right, it'll just be a one-on-one, so there's no surface to be made from an interior and an exterior curve, right? So we need to give this something like we'll do 100, okay. Ooh, maybe he's too high, I don't want that there. 125, how about that? Okay, 0.125. It just needs to be within 1. Okay, and then that'll be our lower boundary, and then this will be our higher boundary. Okay, but both of them I'm going to keep from true 0 and true 1. Okay. So yeah, so I almost wonder if we want to see that panels. Panels will show us kind of what we're doing. So we have our source, and that's from 0.3 to 5. And this is going to be from 0.125 to 0.925. And these will then be our series of remapped numbers. Okay, right. So everything is now going to be within 0 and 1. Cool, cool, cool. Okay. Phew. I think that's probably the trickier part once you get to the remapping, because now it's just a matter of pulling down the whatever it is we want to adjust, right? So we want to adjust the scale of these, so we can grab our scale, and then we have our center point, which is our hexagons, right? We have the geometry, which is also the cells, and then we have the factor, which is our mapped remapped percentage of whatever this is. So if I start to look at this, so if I look at what's happening, see how we're pulling in within 5 cells of this attractor point. If I go in and I change this, we'll start to expand. We start to expand that radius, right? And as I start to shift this in, we start to grab numbers only within 6 feet or only within 5 feet, 4 feet, 3 feet, done. Okay. So that's what that's doing there for our minimum. And then we have the constructed domain. Constructed domain it just helps to see it visually, doesn't it? Like you have the 0.25, that's going to be changing the center radius, right? So the center scale. And if we go 0, it does seem to work for the 0, but if for 1, if I start to go to 1, if we have surfaces here, these just lapse on themselves. They don't exist. So why don't we add surfaces and we can see that. But I think this kind of visually shows it, right? You can start to see the offset of that scale. Right? And as you go to 1, it just, see what I mean? It stencils over itself, and then there's no surface to be made. So you want to kind of make sure this one still works, but this, yeah, especially the domain end doesn't really want to. Okay, so once we get the scale, then we can start to do the boundary surfaces, right? So we have boundary. If we pull in our geometry, that'll give us the centers of these. But if we merge them, so you see how I have inserted a merge here, this is going to grab both. So I want to grab the scale geometry because I just don't want the interior. I actually want what is between the original cell and that scaled cell. So if I do a merge, then I can grab those. Okay, merge data stream, and I want to graft each of these. Okay, first, and remember, graft is going to give us a list of lists. That means that each list will then talk to the next list, right? Every 0 line item will talk to the next 0 line item. So I'm going to input that instead here, and input my data into the second field, and then go way back to my original cells, pull that, and input that into my D1. Okay, and then you can see that it's now doing the inverse, right? It's showing me the border between the inner cell and the original cell. Okay. And then if I give this an extrusion, we start to have what is similar to what we just worked on for the Voronoi, which is a kind of arrayed pattern with some thickness, right? So they'll give you, two guesses as to what this script down here does, where it applies it to a warping surface, of course. So, but yeah, so that's mostly it for the attractor point part. I would like to also kind of show you that it doesn't have to be just a point that does this. We can switch this out and we could bring a curve in or other piece of geometry that we want to use as our attractor. So I'm going to go back into my Rhino space now, and I'll make a new layer and just call it curve. But in this curve, so if I do a kind of random curve here, using my interpolated, right click, set one curve. Okay, if I input this instead of the reference geometry, you'll see it update, and that is going to start to pull within 5 feet of this original curve all of the scales, right? It's going to start to weight the scale that we've set up here to work within, I guess 6 feet we have set up now, 6 feet of the curve. Okay, so we can start to adjust that. And of course, once you start to get a little more complicated, it starts to get slow. Okay. Okay, so it's kind of a nice thing to know that you can do. You can flip between them and try different design solutions, all just with the similar script, but a different reference. Okay, so I'm going to flip this back. Okay, turn this off. And turn these off. Okay, so I think the other thing is to kind of go through and organize yourself, right? So I think I gave a different scribble for this guy. I did pull point. Okay, and then this is my remapping. This is my scale. Not why am I over here? Oh. Scale. Then I merged them, created a boundary surface, and have some extrusion. Okay, so I would probably say scribble make 3D. Okay. I think I also like grouping just because it, without grouping, things kind of look a little more intimidating than they actually are. Groups, it kind of helps you break it down, right? There's 1, 2, 3, 4, 5 steps, and it's not that bad. So, okay. So I'm going to, I think I've flipped back and forth enough that you probably have caught anything that was a little different, but I'm going to leave this up here for just a second, 10 seconds probably. And if you want to, check your script, make sure that all the things are where they should be. Okay. All right. Just checking that you guys are not lost or anything. Okay, so looks like we do have some time, so I think I can go through that second part of the script at the bottom. So once we have this set up, right, now we can use surface morph again to apply that to any other sort of warped surface. I'm going to set up my own warped surface, so I call this a butterfly surface. This is it's just a, here, turn this on. There's some curve that I am using to readjust my points. So there's some sort of move multiplier that gets applied across the points that then form the surface. Okay, so there's a surface from points capsule here, and it's really just coming from a series of moved points. So I can just adjust this and start to shift these things up and down. Thought this was pretty cool and pretty related to what we had already done, right? It kind of gives a little more context because you've already done surface morph today, and now you get to actually apply it again. So, all right, so let's get this set up. I'm going to turn off, I think, what I've got over here, just because it's a little maybe distracting. Okay, and we'll focus on setting up the surface for us to morph onto. Okay, so part 2 of the script is the butterfly surface. You can see I used a rectangular grid. So up here under the vector, I went to the rectangular option and pulled down that to kind of create a base grid from which to work from. So we can do the same thing. We'll just follow along. Rectangular. So if you could pull it from your menu, it's here. Otherwise, you can go up to your grid and grab that. Okay. But it requires some plane. We could work within this plane, but that's kind of where I was working with my other geometry. So I moved it to X, Y. Okay. And then I had some move, right? Move. Okay. And I moved it in the Y direction, right? I moved it this way. So Y, and then I gave it some factor, and this was 30. Okay, so that was my base plane. You can see that update now. So once I had that set up, then it was a matter of giving it some information. So I need some X and Y size, that's the size of the cell itself, and then the extent is going to be the extents in either X or Y direction. So you can, of course, make these whatever you want, but I'm just going to continue on with what I've already set up. So X2, those are my grids then. Each are 2 foot. And then if I make this extent X, copy, paste, make this 12. Okay. So it should look something like that, where I Control G and give it a scribble of my base grid. Okay. All right, so once I have that guy set up, then I need to, I'm going to pull the points again, but this time I'm going to pull them and use that distance as my move. Okay, so whatever distance I pull them, they're going to move up that far. So the points that are further away from whatever my center geometry is, my pull geometry, that distance will be the relationship. It will create the relationship between how high they move then in the z direction. Okay, you can kind of see that here, right? I have some base curve that I've made, and as we get further away from that curve, these start to move up in the z direction. Okay. Okay, so let's look at how we do that. So we need to grab the not sure why I did that, because those should be the points. Oh, there's the edge points, right? So I have to grab, that's why. Okay. So we needed some point for a relationship to pull. So we need the center points of every single one of these cells. So I needed that polygon center capsule. I could also use the area capsule, but this is, either one works. Okay, so I have my series of points, and then I need some base curve or something to create a relationship from, right? So I need something to pull my attractor curve. So we need to draw that in Rhino space. So I have my curve here, and we have to go into Rhino space and set that up. So we could do what I just did, which is to just, randomly draw something that works. I learned a cool new thing, so I wanted to show it, which was I'd never used blend before, and so I wanna show you that because I thought that was really neat. So I'm gonna go to my grid here, and I'd already baked this, by the way. So you should probably also, if you wanted to follow this, you can right click and select bake, and then bake onto your own grid layer. Okay, you can group them so they're all together, but it's really just a reference for this next part. Okay, so once I had it baked, then from this I drew a line. Okay, actually I'll draw a polyline. That's what it was, polyline. So in the 2D space, you had to draw from the corner point and then hold shift or keep your ortho on and draw a line in one corner in the same direction, and then click enter and draw the same sort of polyline with your ortho on in the other corner, but these should be parallel. Okay, and then I typed in blend curve, and it says select curve to blend. So I chose 1, chose 2. Oh, there we go. It was flipped. I drew it the wrong direction. So I don't know if you saw that. It was going the opposite way, right? It's following that end point. So I just needed to flip the direction and change that. But then what it does is it creates a kind of approximated curve geometry between those two those two curves. So it's kind of a blend of them. I thought that was really quite cool, and I can't believe I've not had to, I haven't had to come across that before. So, so I'm just going to move that so it's a little more centered. Okay. So that's going to act as our weighted geometry. Okay, or pull geometry. So if I select that and then I right click and the curve that I made, set one curve, now he's going to act as that in Grasshopper. Okay, so if I do pull point again, pull point, and I pull my center point of my polygons, right? Center point of the polygons, and I give it the curve geometry here, it's going to pull those points from the location A to location B. And with that, there's going to be some distance that's calculated. Okay, so I'm going to group this, right click, blob, right click, color. Use a reference. Okay. And then what I want to do with that is I want to use that as a control, this distance as a control for my move in the Z direction, right? So I want to move all these points up. So I'm going to select my move capsule. I'm going to give that some Z unit. And then the points that I want to move are going to be these center points. Okay. But then if I move this distance, it's pretty intense. Okay, so if I look at that, it's pretty intense, and there's no, it's a one-to-one relationship between this point and this point. That whatever that distance is, that's how high it is. So if I put in here a multiplication in between these two, I have at least some control over what is happening. So I'm going to give it like a 0.25. But then I can start to kind of, at least play with that surface, and like I said, have some control over what height that is. Okay, so I'm going to right click and say, that's my height. Group that and give it a unique color. I haven't been very consistent in my colors today. I think except for him. Okay, so that's going to be the moved points, and then what I can do is I can pull a surface from points capsule, and what that will do is it'll approximate a surface about these points, but it does need some sort of U count. So we can use the U value from the very beginning grid that we made. So go back here and we'll say it would be this one, the X count. We can use that guy as our U. I bet I have to flatten, don't I?
What was used for the 8 count?
The
Sorry.
Right, yep. No, the U count, I had to go way back to the beginning of my script and pull that from my X that I used for the rectangular grid, the original grid that I made that guy. So he had some value in the X direction, so I took that 20 and I pulled him over and I put that in my U count. But notice it doesn't like this, and that's because I would need to, if we look at a panel, if we look at a panel, it's because they're not all together. So what it's trying to do, a surface from points, is trying to create a surface from this set of points, and then another surface from this set of points, and so forth. And that does not work for surface from points. What it needs is it needs a flattened list. So it needs one singular list of points, and then it can start to try to make a surface. So we're just going to right click and choose flatten. And now what that's going to do is it's going to work. It's going to create the surface from those points. Okay, so you have to flatten those points as they come in. Okay, and I'm gonna just turn this all off then so it's not distracting. We can kind of see how that surface is working. So if I start to play with that height, it starts to adjust. Okay. Okay, so this is going to be, what we've just made is we've made what is going to be the base surface that we're going to apply our attractor um, onto, right? This guy, our attractor array. We want to take this and then morph onto this surface. So we need a surface morph, right? Pull this up here. Pull this down. Okay. So surface from points. We need a surface morph. So again, we need this bounding box to make that happen. Bounding box is going to be our reference for the surface morph. And then the geometry, I've disconnected it, so when it's very slow once you do this because it's trying to run the script and then morph onto the secondary surface. So kind of know that when you do this, it's going to maybe take a little bit of time. So so I'm going to do that. I'm going to grab our surface morph. Surface morph, way up there. Why doesn't it know I just want that one? Okay, surface morph, and then I'm going to grab that bounding box again. We need the bounding box as the reference geometry about this as a unit. So again, it's per object, so we need to right click and union box. And then we'll pull in this extrusion. Okay. And I think, let's take a look. Do we have to flatten this? Yes, I think we should. Let's flatten. There we go. And you can see here, if we don't flatten it, what it's doing is it's going to create a bounding box about each of these cells. So we need to flatten this so it understands this as one solid unit. And then union box will also do that for us. Okay. So once we have that, now we can start to plug into our surface morph. So surface morph, again, we need our geometry, which is going to be what we did with the attractor script. Okay. Right. Then we have our reference box, which is going to be the bounding box. Right. And then we have the surface that we're going to morph this onto, which is going to be this guy that we've just made. Okay. And he's still not going to be happy. We need some sort of U and V domain, so we can pull the domain from. I think I did. Yeah, I just did one. I did the same technique again, where it was I reparameterized this and I just set the U and the V to 1, and that way it creates a one-to-one relationship to our morphed surface, right? Because these are different sizes. So I'm just going to say reparameterize the whole thing and assume this is 0, this is 1, this is 0, this is 1. And that way it will, it should just morph directly onto it. And then the last thing I need is I need some sort of height. So we can again do maybe 1.25. Now we're going to plug this in. And if you do want to adjust the height, I'm just telling you, it might be a little slow. So be patient. Same thing with this. We're going to plug this in. Okay, give it a second. It's going to think. Woo! So we have a couple of things happening, but it definitely definitely works. So you can see how it's taken that base, what was the base patterning over here, and now applied it and morphed it onto this new surface. Okay, and because of all the parameters we set up, we have quite a lot of things happening, right? We can change the height of these edges, which if I do this, you'll see how slow it is. I'm not going to change too many of these, obviously, since it takes quite some time to update. So I would suggest, if you to use these parameters, or as as a parameter design, if you are still designing the surface and the pattern you want to apply it, I would do them separate and then bring them together at key times. Like I showed you, I have this disconnected over here, and that's simply because then I can work with the script as its own thing, figure out the patterning, and then go back and apply it to whatever surface I want to apply it to. Just want to see if I input this geometry. I think it might get a little bit of an interesting patterning. It'll be the last thing I change though, because we only have a couple of minutes, and I don't want to waste time with grasshopper thinking. Yeah, kind of interesting. It'd help if the curve was the same curve. But yeah, okay. So I'm going to, bounding box is kind of his own thing, so I'm going to group this, give it a scribble. Surface morph. Okay. Probably this down here too, surface from points. What did I call this before? Move points. Okay, that probably makes sense. Okay. Don't want these things crossing too much. Okay, and then I'll zoom out here, kind of try to give you an overview. So this was our first part. I'll leave this up for a few seconds for you to copy. Make sure you have everything where you want it. This was to make the surface, right? To move, and then you have some relationship, and then there's a height to those wings, the butterfly wings. And I created some sort of surface from points. Remember, I had to flatten that list to get that capsule to work. The U count being pulled all the way back to the beginning from the rectangular X extent. And then this surface became the surface we morphed onto. So we had to do two things here. We needed a bounding box, and we had to take the patterning that we have. We had to flatten that list and use that as our content. We had to change this to union box. And then that was we had our geometry as our reference, or sorry, our geometry, of course, is our geometry. And the box as the reference box. And then the surface that we morphed onto was that surface, the butterfly surface we made. Okay. And then I changed it so that it was reparameterized. Right click reparameterize. And that way it goes from 0 to 1, right, for the domain. So we just set 0 to 1. 1 is the domain. And then this is some height here, which we could probably also label. Okay. I think, if you're if you're feeling comfortable with this, that's great, but you don't, for the next week's assignment, you don't have to do the attractor part. That was kind of an addition because really I couldn't think about teaching a grasshopper class without at least one little bit of class going through how to set that up. And it's not too complicated. I don't think it's nothing, because we learned remap last week, so it's kind of a similar idea. You're just using this pull point to, in two different ways here. You're just using it to kind of remap those numbers and apply it to either a scale or a move or an offset or something like that. So, okay, so it's 10:50. We are done with class for this week. That was a lot to get through. We went through 3 different ideas, so that's a lot of work. If you have questions on anything, you have to let me know. So if you feel like you're falling behind at all, if you feel like it's, you're not understanding something, you really have to send me an email because I don't know. I'm not a mind reader. I want you to do well, and I can't help you if I don't know that you need help. So, and it's, that's why I'm here, and that's why we're in a class together. So it's to learn. So,
I have a question.
yeah.
It's for the assignment that we're supposed to turn in for today.
Mm-hmm.
I've been trying to look for inspiration and I finally got it. But
Oh, that's good.
so for is it possible for us to be able to twist a shape in response to like the sun?
Hmm.
Like it would turn to shut itself off and then it will open up and kind of like untwist itself to allow light in.
Oh, cool. Um,
So,
yeah.
because I'm trying to think about it, and I'm trying to figure out like how would everything connect,
Okay.
and I just
Do you have your reference available, and do you have any part of your script set up that I can take a look at? Um,
I don't. I've just looked, and I don't think there's really a reference for it. It's really just me just thinking about it.
okay. How about so I'm going to I don't want to drag out class here. Do you have time right now if I give a few minutes to like let everybody sign off? Do you want to sit and we can maybe brainstorm a little bit?
Yeah,
Because you
I
have
got
another
so
class. It's
well. I have class at 11:15, so
oh, okay. All right. Well, then we can talk for a couple minutes before you sign off,
yeah.
at least to give you some direction. But if nobody, I just wanted to say, like, if nobody else has anything else, you're free to go. I'll see you next week. But let me know if you have questions, and the same goes for the midterm reviews that you got too. So if you have questions about anything, any feedback, send me a line. Okay. So other than that, have fun. Remember, this is the last grasshopper fun assignment, so enjoy it. Um, Everything else will be V-Ray and maybe some Enscape. And I'm trying to download. I downloaded Twinmotion, haven't gotten that to work, of course. And Lumion, it requires insane specs. So I don't know how you guys are working on like for your computer. Like I don't have that kind of graphics card, and I thought I had a good graphics card. So I'm not sure I'll be able to go over that without some sort of yeah super capabilities, and then you too. So I don't know if we might have maybe one. I think Anthony, maybe if you could show us um, that'd be great. But otherwise, I think we'll just stick to V-Ray and Enscape since those are relatively attainable. Okay. So otherwise, I'll see you guys next week. Okay. I'm gonna stop. Okay. All right, Priscilla. Yeah. So okay. So you want to twist this thing? Twist.
Yeah, I haven't really started it yet, but like what I'm thinking is that like I'll share my screen real quick.
Oh, you know what? Let me stop. Well, you share your screen. I'm going to stop recording. We don't need to this to be up.